Okay, today we're covering head tech, okay? Like cylinder head tech, not that kind of head. So, as I discussed last week, the 2.5 Chevy that I was working on is just like a 306 on a Ford. It's got the intake and the exhaust on the same side of the head, right? So we have intake on this side and exhaust back here. And on these other engines, some of them, not all of them, but some of them, straight six Ford, from the factory head, will have like exhaust, intake, exhaust, intake, exhaust, intake, exhaust, intake. And that is called a counterflow head. This is called a crossflow head. And this, if you look, just observe the bolt pattern and then take a look at the valves, okay? So they're straight. And that's very common just to have, and they're for the rocker arms. They're made that way so the push rods can come straight up and have a straight shot, all that shit, okay? Now, the reason that they came up with overhead cam engines is so that they could put the intake valve on this side and the exhaust valve on this side, and airflow would come naturally here to here, right? So it would act more like a vacuum or a turbine engine, okay? So you have a constant flow of air, and there's nothing to really interrupt that. There's no elbows, there's no bends. On a counterflow head, it's got to come in, do a 180-degree turn, and come back out. And I know it doesn't seem that way when you think about it as in, combustion, out. But when it's flowing, right, when you have 50 gallons a minute or 50 cubic feet a minute of airflow, then it matters a lot. Just like a two-cycle engine, it comes in one side and goes out the other. And when you get your crankcase filled up with a fuel-air mixture, it turns into a ball of fire, right? We've all rode those two-stroke bikes, and when that power band comes up, understand, no matter what anybody tells you, a power band is not a mechanical device. It is a natural phenomenon in a two-cycle engine when the crankcase pressurizes with a fuel-air mixture. Once that happens, the air goes straight through it, okay? That's the power band. It's not got anything to do with mechanical devices. So don't believe any of the bullshit that people are going to tell you. It's bullshit. So, anyway, crossflow head, rocker arm, push rod, crossflow head, push rod design, right? The air has to come in, and then it gets combusted and has to come over and out. In an overhead cam, it comes straight through. There's a couple little Humpty Dumps because inside you have the combustion chamber. It comes in, combustion chamber, and then goes out. So it kind of Humpty Dumps just a little bit, but for the most part, it's pretty effective. But if you have a V8, a long timing chain is a bad design. But I want to show you another design. And this is for a 302, 351 Windsor, okay? We'll turn this so that you can see it right there. And it has right here water jacket for a cooled intake manifold, okay, or a wet intake. So there you go, there's that. I want to show you this though. This is key. I know it's a little dirty and it's a lot heavy, but if you look at the setup on the valves, they're cockeyed. You see that? So when the air comes in, it comes through the intake here, through the valve, and then curves back around and goes this way. It's more of an S than it is coming in and doing a 90 and another 90, or a 90 here, 90 here, 90 here. You know what I mean? This is a Cleveland head. Now, if you look closely, where did it go? It's here somewhere. Well, we'll just turn the intake in. So see here? You see that? It's a plug. And then you look at this, and you see a water jacket right here. You see that? And as a matter of fact, I can put them side by side. Does that look similar? Does that look like it might just bolt up? Just maybe, just maybe. Listen, if you take this guy right here and you hog that out, top and bottom, open that up, and then you come around here, whoops, come around here to the underneath side. And you see that? You see this right here? So you take this right there and you weld that shut, and you weld that shut down there. Guess what? You've got a Cleveland head that will breathe better, that you're going to bolt up onto your 302. That's right. This head right here, if you already have cast iron heads, you're good. Of course, this is a Brodix. This is a high dollar racing head. So we're carefully, ever so carefully, going to put that down back on the ground where it belongs. But this cast iron head, if you already have cast iron heads on your 302, you can turn your 302 into a ball of fire. Now understand that a late model 302 has roller cam and roller lifters. That means the node on the cam is like this versus rounded like this. Okay? We'll go over that another time. But with a roller cam, it's when you got a real sharp ramp on your grind. It'll have a roller lifter on it. When you do that, you have to change these valve springs right here. Okay? And understand that a Cleveland head, it's the same as modified 351 400, 351 Cleveland, all the same. This head has a very short tolerance from the valve spring keeper to the deck of the motor down here. Let me turn it. So from here to here, just barely a ½ inch. So measure your rise on your lifter and make sure that the rise on that is under a ½ inch. And you may have to shim. You got a shim kit, and you shim right here in that little flat, squared, notched out thing. You can shim it with washers. You just cut them square and you slip them down in there if your rise is too high. But before you do anything, take these valve springs out, and you need to put, I want to say 125 to 160 pound valve springs. Might be 160s. But you gotta put heavier valve springs in them, because they'll start to bounce because of that sharp ramp. The valves have to snap back twice as fast when you have a roller motor. So one thing to consider when you go to a Cleveland head on a Windsor engine, you need to, number one, measure the lift of your cam. Number two, change the valve springs on your valves. And the lifters will come up in the same spot, right? And the lifters, will hit the rocker arms, and the rocker arms will actually be at an angle. That's fine. That's not a problem. And you can actually, I have a device here somewhere. It looks like a push rod, but it's got a little bolt in the middle of it. And you can adjust it and stretch and shrink it. And you can put it in there and specify what length you want your push rods to be and special order your push rods. That way you get that push rod to where the top of the push rod, and probably if you're going to do this, you'll just go ahead and order roller rocker arms. So when the push rod is on the rocker arm, the ball of that rocker arm, since it's going to be hydraulic, is going to be right there, and you'll set it around 10 thousandths gap right there. And it's supposed to contact right in the middle of the valve. Not too far this way, not too far this way. And what adjusts that, where it lands, is the length of your push rod. So just a heads up, you find yourself an old Cleveland motor, 400 Ford, and it was a 2-barrel intake, but this, mind you, this set of heads is for a 2-barrel vehicle. This is for a truck with a 2-barrel carburetor on it. This is the smallest head they make for a Cleveland. It's a 2V head. They have a 4V, but the intakes on the 4V are twice that big. You can fit like 4 fingers into the 4V heads. They are enormous, and they just don't run right. Unless you've got direct injection going right into the intake right there, they do not run right. So just get you a set of 2V heads. They'll breathe better, and they'll go faster. But I want to show you this. So if you compare race heads, this is high performance Brodix racing heads. Look at the intake here and look at the intake here. And you can see that the Cleveland head has a bigger intake than the Brodix high flow aluminum racing head. So, you know, if you're making a zero clearance engine, you have to have special pistons to account for the valve reliefs on your offset valves. But if you look at the valve size, you see the valve size? They're about the same size valves, right? Yeah. So if you want to turn that 302 into a beast, you need to get you some high pressure valve springs. You need to measure the length of your push rods, and then get those measurements that I talked about on your lift, and then do these modifications. Weld this thing shut here, and then over on the intake side, bore a hole. And then you'll have to do that on the front and the back so that you'll have a wet intake. Otherwise, you won't have water flow, and it won't run right. It'll get hot, and it'll be a mess. So do these things. Put this on your 302. It's called a Clevor. You're blending a Cleveland and a Windsor engine together. There's a few modifications to do, but this is twice as big as far as valves and intake as the cast iron 302 heads you have on your 302 right now. And if you have a 351 Windsor, I would not recommend this because the middle of the block will break when you start putting ass to a 351 Windsor. It's a ½ inch taller deck than the 302. Still a Windsor motor. 302 is still a Windsor motor, but it's got a ½ inch shorter deck on it, and the casting for some reason is almost indestructible. But don't be doing this to a 351. You'll ruin it. Keep your 351 stock. If you want to build something, build your 302. It'll fit. You use the same heads. I'm pretty sure the exhaust manifold's the same. The only thing's different is the intake, and main journals and shit like that is a little different, but that's got nothing to do with it. Your oil pan's going to be the same. Your exhaust manifold's going to be the same. Heads will be the same. The only thing really major component that's different is that intake manifold. I hope this helps. Let me know if you have any questions about this. And if you're planning a 302 build, keep in touch.